Okay, so the warm up today, again, this one, I can pretty much guarantee you'll see one like this on the AP exam in May, on May 9th, which is also National Non-Abbreviation Day. So again, like when you're writing VA in here for vertical asymptote, that's fine. But you know, on May 9th, you would write out vertical asymptote. Okay, so it's continuous everywhere except at 7. Find the value of K. Well, piecewise function, left and right, it's that rational function. At K, or at 2, it's some K. We got to find K. So, I mean, if you read about it, it might kind of lend itself to the fact that maybe the function up top, we're not using it at 2 for a particular reason. And if we can correct the flaw, maybe it's a removable discontinuity, right? Because that's the only one that we can fix by putting it back. So that's what happens. It turns out that this top piece by itself has a vertical asymptote at 7 and a hole at 2, at x equals 2. And basically, we need to find the y value of the hole so we can plug the hole to make it continuous there, right? So what we're going to do is we're going to go them off to the side and we're going to factor the top. Now, I'm not going to call the top f of x because it's not. It's only the majority of it. So let me just factor it down here off to the side, x plus 2, x minus 2. And then the bottom is x minus 2, x minus 7, if I did it correctly. Yeah. And so now you can see that that divides out. And yeah, there's the vertical asymptote factor at 7 that we can't fix. It's non-removable. And then how do I find the y value of the hole? I plug into what's left. Now, here's what I'm going to do. I'm going to say at x equals 2. Again, even if it's just bench work, you want to have some semblance of like normality. So when you have variables and then underneath there, it turns into numbers, there has to be an indication of how you're doing it. Either you have the limit in front and then the limit disappears, or this says f of x up here and now it's f of 2. I can't do that here because it's not f of x. I could write the limit here, but I chose not to. So saying something just like at x equals 2. You're not claiming that is the function value. You're just saying, hey, I'm plugging in a 2. So I get 2 plus 2 over 2 minus 7. And that is, if you simplify, 4 over negative 5. So negative 4/5. So what does that mean? That means that that function up there, the top piece, has a hole at the point 2 comma negative 4/5. And if the entire function has to be continuous at 2, then what do I want K to be to plug the hole? Negative 4/5, okay? So if this were a free response, we would say a concluding statement, so K equals negative 4/5. Again, it's either 4 over negative 5, negative 4 over 5, or pull the negative out front. And that plugs the hole, and it makes it continuous at that point. So it's just it's a way they've been asking this type of question for a long time. If this were a multiple choice, of course, no one's grading your work. Do as little work as you need to so that you don't confuse yourself, but still get the right answer. Yes, Mason.
For like short answer, would we have to put so K equals negative 4/5, or would we
just put K equal? You could just put K equals. But let me talk about that. I like to write so for a couple of reasons. It does indicate that there's kind of a transition in thought, right? I'm collecting evidence, I've come up with an answer, and now it's kind of like therefore, right? In your science class, therefore, and now you're making your final statement. But so, or consequently, or ergo, so is only 2 letters, so it's shorter even than just writing the therefore triad. And to me, it's like so blue collar, right? So when you're like, so it's kind of like, I'm not an elitist. I've learned to do this by toil and hard work in sisu. Will you get points taken off if you don't have it? No. What is sisu? You're learning it right now. It's right there. No, you can, I'll explain it later. Yeah, right now you're just learning sisu in the background. Yes, ma'am.
Okay, so you can put like f of 2 because it wasn't the original function. Is that why?
We can't put f of 2 because at the time we don't know what f of 2 is. We're trying to find what f of 2 needs to be. And if you put f of 2 and you plug it into here, you're kind of saying that I'm using this piece at x equals 2 when it forbids it up here. Does that make sense?
So
Yeah.
you can put
Right, yeah. Now, in hindsight, looking back, because we did plug the hole, now what is f of 2? When x is 2, it happens to be that. But that's kind of after the fact. Yeah. Right. It's just that one piece. Yeah, so when in doubt, just say at whatever. And that's enough to indicate that you're plugging something in. It works all the time. Sisu is basically the Finnish version of ganas, which, is the Spanish or the Bolivian version of persistence, perseverance, positivity, unrelenting enthusiasm. It's a whole bag. I like to describe it as, because it's a Finnish term. My grandfather, was born in Finland. It's the trait that allows the Finnish people to coax potatoes out of the frozen tundra. Let that sink in. All right. So let's go ahead and move on. And we are on, let's see, okay, we're still recording. All right, so when you get back from lunch, the quiz is not designed to be long. It's designed to be kind of short. So like, it's going to be like the 3-step definition of continuity. I probably won't even put one on there like example 9, just because I know that you'll know how to do that. So I don't need to quiz you over that. What I'll probably do is I'll just give you a piecewise function, and I'll ask you to discuss the continuity using the 3-step definition, like at 2 different places. Okay, and then maybe tell me what type of discontinuity we have there. Okay, short, sweet, to the point. All right, so here's kind of what I've been alluding to, but this is going to be so important moving forward when we're evaluating limits from here on out. It's the general limit definition, but it's backwards. If a function is continuous at a point, then of course we know the function value and the limit value are the same. And I put y value in there because I still want you to bear in mind that right now we're talking about inputs and outputs. The outputs are the y values. We have 2 different outputs now. We have limit outputs, y values, and function values. But if a function is continuous at a point, they're the same. Now, why is that important? Well, in calculus, you're probably going to be asked to evaluate a limit, right? Whereas in algebra 2, you were asked to evaluate a function. If the function's continuous at the point in question, it's really the same question, right? So on example 10, it says evaluate each of the following limits. What is the limit as x goes to 1 of this 5th degree polynomial? Well, if you don't know anything about calculus, you're probably looking at like, well, that looks hard. Looks really hard, right? But if you're in algebra 2 and I said this function is f of x, what is f of 1? You're going to be like, oh, I know what to do. I'm just going to plug a 1 in for x. It's the same thing, right? Now, we can do that because polynomials, like this 5th degree polynomial, are continuous where? For all real numbers, everywhere. Yeah. There's a lot of functions that are continuous everywhere. Over their domain, that is. Like sine and cosine are continuous everywhere. Even the natural log of x that only lives to the right of 0, it's continuous over its entire domain. Yes, it is. Yes, it is. Yes, it is. Yeah. So how are we going to know if a function is continuous at a point if we don't recognize it? Well, unless it's a piecewise function, which are kind of the exceptions to every rule, or a piecewise function in disguise, like hombre trepador, which you'll meet here shortly, Señor Salta. If you plug in a number and you get an output, that means it's continuous at that point, and that's not only the function value, that's the limit value, okay? Very good. So if you had to find the limit as x goes to 1, let's just use direct substitution. Once you plug in, you don't write the limit anymore, right? So it's just 4 minus 7 plus 3 minus 1 plus 1 minus 5. If this were a free response question, we're done, right? We're walking away. But if it's a multiple choice, you think that's going to be an answer choice? Not. So we need to simplify it carefully, right? We get a negative 3 plus 3, that's 0. Negative 1 plus 1 is 0. We get negative 5. Oh, a lot of cancellation going on there. Pre-cal today learned the difference between canceling and dividing out.
Oh, wow.
It was a big day for them. Yeah. The negative 1 and 1 here cancel to give you 0. Things divide out to give you 1. All right, there you go. Piece of cake. Letter B. This is now my clever way to ask you about the unit circle. On the quiz, I'll say simplify. The limit as x goes to 5 pi thirds the cosine of x. Well, direct substitution gives you cosine, 5 pi thirds, yeah. If this were a free response, can we stop there?
Yes.
Yes. And the reason is because, you gotta be careful, cosine of 5 pi thirds exists, okay? So we could stop there. If I asked you this, the limit as x goes to pi halves of tangent of x, and you plug in and put tangent of pi halves, could you stop there on a free response? No, because tangent of pi halves does not exist. Okay, so you got to be a little bit careful, but you know, if it's defined, it's good. All right, maybe one. Yeah. All right, or maybe 2. I put it at back end. It's got to be fast. All right, so what is cosine of 5 pi thirds? It's 1/2. Good. All right. All right, part C. The limit as x goes to e, again from both sides, of the natural log of x over 2. Well, direct substitution is the natural log of e over 2. Free response, stop there, yes?
Yes.
Yes, and it's because the natural log of e is defined. Remember, the natural log's domain is everything greater than 0. So if you're plugging anything in greater than 0, it's going to work. Now, simplifying, what is the natural log of e? 1, so we get 1/2. And you really need to know, like, the natural log of 1 is 0, the natural log of e is 1, and then, of course, the natural log of e squared is 2, the natural log of e cubed is 3. Okay, there you go. So what this is going to amount to then is in the future, especially when we get to 1.4 where there's a bunch of them, never not first, direct substitution. Never not first. Direct sub, and yeah, never not first. Always first, right? You're going to plug in. If you end up getting 0 over 0, or there's another type, infinity over infinity, that's when you have to do something like we did on the warm-up, factor, divide out, and plug in. Otherwise, you're going to have a result that's conclusive, okay? All right, let's look at the infinite discontinuity, also known as the vertical asymptote. It is, it's non-removable. So as you approach vertical asymptote, assuming the graph exists, there's really only 2 things that can happen. You either increase without bound towards positive infinity, or you decrease without bound towards negative infinity. That's it. You can't like sneak through the semi-permeable membrane there, you know. By the way, the dotted line is not part of the graph, is it? It's just something that we put to help ourselves visualize what's happening. Okay, now that's going to happen at a specific value of x, call it c, which is different from end behavior. If you think about a parabola, as we go out to the right forever and ever and ever, that's a one-sided limit, it is going to increase without bound. That doesn't mean there's a vertical asymptote out there at infinity. That's the end behavior. This is when you're approaching an actual finite x value. If your y values increase without bound or decrease without bound from either side or both sides, it's going to be a vertical asymptote. So we can define it, right? If for some function f at c, if one of these 4 things happens, you approach from the right side and the y values go up to infinity or down to negative infinity, and or you approach from the other side, the left side, and the y values increase or decrease. Now again, at most, you can have 2 of these, right? One behavior on the left side, one on the right side. Or it could just be on one side, like the natural log of x only lives on one side. You can even have the graph existing on both sides, but the vertical asymptote only affecting it on one side, something like this. Okay. That would certainly be a piecewise function, but if you can define it so that it passes the vertical line test, that's fine. Okay. No, well, it would not be continuous. It would be defined. So like it would be in the domain, but it still would not be continuous. Okay. Yeah, because on the left side, it's going up to infinity or down to negative infinity. There's no way it's going to connect with the point that starts there. But the domain can still be all real numbers. Yeah. It would just end up being a piecewise function. The vertical asymptote, like the jump, is non-removable, meaning you're never going to be able to make it to be continuous and still have just one point defined there to be a function. Yeah.
I think you said this yesterday, but I just want to make sure. So do you have like a limit for infinity or negative infinity?
Correct. Yes. So over the years, some BC people have gotten together and said, hey, let's come up with our new class motto. Okay, what is that? When in doubt, DNE. Okay, break. No.
It's not a good.
Right. Very good. When in doubt, and you're evaluating a limit, DNE. And there's several reasons for that. When you say like this, when you say the limit as you approach from the right is infinity, you're really saying two things. The first thing you're saying is that the limit does not exist. Because, now the second thing is because it's increasing without bound, we say. So you're really saying two things. You're saying that it doesn't exist, but then you're telling me why. So it turns out that if these end up as multiple choice questions, DNE is not an answer choice. If there's a vertical asymptote, they typically ask from one side, and you have to know if it's positive or negative infinity. Okay, that means advisory's over. Yes. So when in doubt, DNE, because DNE is a catch-all category for many things. The limit can fail to exist for many reasons. It could be that the limit fails to exist because the graph is increasing without bound. It could be that the limit fails to exist because it's approaching two different things from both sides, right? Like a jump. And it could be that the limit does not exist because, as you'll see later, it's oscillating between two fixed numbers or something like that. So limits can fail to exist for a lot of reasons. And on any free response or short answer, DNE is an acceptable answer. Yeah. So what I would say, and I amended their motto, right? When in doubt, DNE, and then I said, okay, I'm going to add something to it. Get rid of the period or the exclamation point, maybe, comma, but don't ever be in doubt, exclamation point. Okay. All right. So, and then it works the other way around. If we know that the function has a non-removable infinite discontinuity, that's the formal name for the vertical asymptote, then we know one of those four things happens. Okay. So let's take a look at example 11. For each of the following functions, without a calculator, let's answer them. Let's try to answer it as accurately as possible. And then we'll see, okay, let's give the safe answer. The safe answer. Like using your boat in the harbor only. The safe answer. That's not what boats are for, right? Number one, the natural log of x. Well, if you can visualize the graph, it'll help answer a lot of these questions. The natural log of x is one of your parent functions. If you look on my website, there is a catalog of parent functions that you should know. So you should probably look at that every once in a while. And the natural log of x is one of them. We spend a lot of time in pre-cal studying it, right? It passes through the 0.10. The domain is everything to the right of 0. And it's interesting to note, of course, the natural log of 1 is 0. But if you take the natural log of anything between 0 and 1, you're going to get a negative number. Like the natural log of a half is some negative number. And if you take the natural log of anything greater than 1, it's a positive number. Okay, That's what the graph looks like. So part A, what is h of 0? 1. Are you sure? 0 is right here.
Oh,
Yeah,
right.
right. It should be D and E. Now, if you want to plug in, notice I have the equal sign there. H of 0 would end up being the natural log of 0. Could we stop here on a free response? No, because what is the natural log of 0? It doesn't exist. No, the natural log of 1 is 0. The domain is everything greater than 0, right? There's a vertical asymptote at 0. Another name for the y-axis is x equals 0. Okay? So here's another kind of notational thing. If you do start a function like this with an equation and you work to the right and then you want to simplify as you work down, it's no longer an expression. So you could treat the right side though as an expression and work straight down. You just need to bring the equal sign down every time, okay? Part B, what would be the limit as x approaches 0 from the left? From the left. Very good. Is there anything over here to jump onto to start heading back towards 0? No. So remember I told you that D and E is a catch-all category? Here's another reason the limit can fail to exist. Because the graph fails to exist there. It's like doesn't even make sense, really. Part C. Now, what's the limit as we approach 0 from the right-hand side? There you go. The preferred answer is negative infinity, which says the limit does not exist because it decreases without bound. The safe answer would be D and E. Sometimes as a multiple choice, a college board won't put D and E, they'll write non-existent. It's the same thing, right? Okay. All right, part D. What would be the general limit at 0? Yeah, can we put infinity or do we have to put D and E? We have to put D and E, all right? And notice from the left side it's D and E, and from the right side it's D and E. That's the same, so this has to be D and E. That's not necessarily how that works when it's D and E, right? The general limit doesn't exist because the right-sided limit doesn't exist, and the left one doesn't really even make sense, right? Questions on that? Knowing the graph helps. Number 2, this is a transformation of a parent function. The parent function is 1 over x. Let's pretend we don't know what the graph looks like, though, because this would be a transformation. What does any graph do when you replace x with x minus 3? Shifts it to the right 3 units. Okay. Now, let's say you don't know what the graph looks like, but just analyzing the function, what's the only value not in the domain? 3. Is it a whole or a VA? It's a VA because it's non-zero over 0 when you plug in a 3. Okay? So I know there's a vertical asymptote at 3. Before I even do it, I know there's a vertical asymptote at 3. Therefore, just in my head before I start anything, if I'm asked what the limit is from either the left, right, or the general at 3, the limit at 3, D and E is a safe answer, right? Because I know there's a vertical asymptote. Okay? What is f of 3? It does not exist. Good. There is no bridge there. It's not in the domain. Okay? What would be the limit from the left of 3? Very good. I'm going to put the safe answer down here. Because for the multiple choice, we have to commit to, we want more than a 50-50 shot. Because it's a vertical asymptote and it's from one side, I know it's going to be infinity or negative infinity. Who said they knew it, what it was? I heard it's like negative infinity. It's like similar to negative infinity, so it's like positive infinity. Negative infinity is like positive infinity. They're both infinity. How'd you know it was negative infinity?
Because if you take like anything less than 3, then it's negative. It's going towards
You used it a couple of times there, and in this class, we don't ever use it unless we're talking about the Stephen King movie.
so
When you take a number
something
smaller than 3, and you do what with that number? Oh, you plug it into the function f of x. That's what you mean, right? You're going to get what type of number? A negative. Now, when you choose a number less than 3, what number are you choosing? Like negative 100? 2.9. That's it. That's how I would coach it, right? You know, because there's a vertical asymptote, it's going to be some type of infinity. You know that, okay? Non-zero over 0, some type of infinity, one-sided limit. To get the sign, you know, as Ella was like saying, you plug in a number from that particular side you're approaching. But you want it to be really, really close to the vertical asymptote. Too far away and the graph's already dancing around doing other things. But the idea is that the asymptote is like gravity. And the closer you are to the asymptote, the more it's already pulled you towards that particular type of infinity, right? So in this case, if you choose a number, I would say that's a tenth away, you know, 2.9, or if you can say 2.99, if you can stomach it, whatever. This one's pretty easy. So I'll go ahead and write. You don't have to write this. This is just bench work, but you could put f of 2.9 here because it's in the domain. That's going to be 1 over 2.9 minus 3, which I'm just going to say is less than 0, right? That's really the important thing. 2.9 minus 3 is a negative number, 1 over a negative number. So a lot of times inequalities are what we're after. So because we're only a tenth away and we're a negative number, chances are it's going down to negative infinity. And guess what? It is. Okay? And you could quickly see, this is a relatively easy one. If you plug in 2.9999999, which is really close, it's still going to be a negative number. So you can say with pretty good confidence. What would be the limit from the right of 3? Some type of infinity, and D and E, we'll get that out of the way. What might you plug in to determine the sign? Something greater than 3, like 3.1. And let's do this one in our head, okay? 3.1 minus 3 is positive who cares is the correct answer. No. Positive who cares. I guess it is 0.1. Looking good. So 1 over a positive is positive. So this is going to be positive infinity. Now, if you left a space for the plus sign, is it okay to put the plus sign? It's okay, but it looks a little strange. So we'll just maybe leave it. Yeah. Yeah. Like someone in pre-cal yesterday, we were talking about -9, and then it was, we squared, or we did something that made it positive. I said, now what type of 9 is it? And someone said, regular 9. So I like that. This is regular infinity. Okay. Now, what would be the general limit at 3? Does not exist again is a safe answer. But with infinities, again, we kind of want to give as much information as possible. It's negative on the left, it's positive on the right. Those are 2 different types of infinity, right? Do you think it's okay to say plus or minus infinity for the general limit? Well, you certainly could. But here are 2 rules then. You can only give 1 answer for a limit. This is 2 answers, right? So that wouldn't fly. The second thing is we could actually put infinity if both the left and right were infinity. Yes, you could. But they have to be the same behavior. And if they're both negative infinity from either side, we could put negative infinity for the general limit. Okay? What's that? That would just be like the definition of the limit. Yeah. But you have to realize you're still saying that the limit doesn't end. We're going to look at an example of that. So we're getting there. But here the best we could do is DNE because it's doing 2 different things. All right, now what does the graph look like now that we're done? Just an FYI, the parent function 1 over x looks like this. It's your hyperbola. It has a vertical asymptote on the y-axis and a horizontal on the x-axis. That's 1 over x. Okay, so the -3 picks it up and moves it over 3 units. So it looks exactly the same, except the y-axis is now x equals 3. Okay, so you could see that it's going down on the left side and up on the right side. Again, that might speed up the process, but you're not always going to have functions that you recognize. All right, number 3, the parent function is 1 over x squared, which again is a parent function. I call it the volcano graph. Incidentally, look at this stat for the day. Today is National Petroleum Day, whoop, whoop. But also on this day in 1883, speaking of fossil fuels, Krakatoa erupted, spewing molten dinosaurs into the air, killing 40,000 people in Indonesia. Yeah. And it's only the second deadliest volcano on record. The deadliest was Tambora in 1815, which incidentally also took place in Indonesia, killing 20,000 or 80,000 people. So yeah, Indonesia's got some volcano issues. All right, let's look at number 3, but without the graph. And when I say let us, I want you to do number 3 by yourself. I'll give you a minute. I'll pause the recording and we'll come back on, okay? On your mark, get set, go. So once again, let's pretend we don't know what the graph looks like. If you just analyze g of x, it's 1 over x plus 2 quantity squared. X can't equal -2. It's not in the domain. It gives us division by 0. But g of -2 would be 1 over 0. Non-zero over 0 means vertical asymptote. So once again, before we even work with the problem, we know going in that there's a vertical asymptote for this function at -2, which means that the limits will not exist. And g of -2 is also DNE. This is not a piecewise function, because remember, with a piecewise function, you can actually define it to exist at a vertical asymptote. That's DNE. What would be the limit from the left of -2? Well, again, the safe answer is DNE. Look at this, part C. From the right, the safe answer is DNE. And look at this, the general limit, the safe answer is DNE. So if it's a free response, I mean, you're done. You're not even messing around. But multiple choice, we got to know if it's plus or minus infinity. So we can use the same little trick. Plug in a number just to the left of -2, like -2.1. And look what happens. -2.1 plus 2 is negative who cares, but oh, look, it's squared. So negative who cared squared is now positive who cares. And because it's a positive 1 in the top, you got to be careful. If that were like a -1, that would flip it across the x-axis. And there's no signs out front either. But when you plug in a -2.1, which is only a tenth to the left, you get a positive number, which means that the graph is probably well on its way going up. And what is it from the right-hand side? Same argument, square it, it's going up. And now, much to some of our surprise, what can we say about the general limit, if anything, more than DNE? Infinity. Yes. So just a word on that. When you say or when you hear that the general limit of any function as you approach a specific value of x, if the general limit is infinity, that means that it's going up on both sides. That's what that means. And if the general limit is negative infinity, you know it's going down on both sides. Okay? Fantastic. All right. What about the next one? Trig. Oh, by the way, let's look at the parent function here. This is why I called it the volcano graph. Because it's squared, it's a little bit steeper than 1 over x, but it looks like that. It has a vertical asymptote and a horizontal asymptote. And of course, the +2 would move everything over to the left too. So the vertical asymptote is at -2. And then, of course, lava spews, right? There you go. All right. Secant of x. Y'all are pretty good with secant of x. This is the function. I don't think we got to the point in my class, but maybe Mrs. Skurhawk did, to get the graph of secant of x. All you got to do is take the graph of cosine, which is chala, and then flip it. So the x-intercepts or the inflection points become vertical asymptotes. The high points stay high and it turns up. Low points stay low and turn down. But look, we don't need to know what the graph looks like. I'll show you why. K of pi halves. Let's plug that in. It's secant of pi halves. Is that DNE or can we evaluate it? Secant is the reciprocal of cosine. The cosine of pi halves is 0. The reciprocal of 0 is some type of infinity. Thank you. Which is DNE, right? It's some type of infinity. I told you that like on the first day, right? The reciprocal of 0 is some type of infinity. The reciprocal of infinity is some type of 0. A lot of people think the reciprocal of 0 is 0 because they think of 0 as like this round number. And when they flip the round number, look, it's still the round number 0, right? But that's not how it works. It's like 0 over 1. Flip it, you get 1 over 0, okay? So it's DNE. It's DNE. What would be the limit from the left? Well, because the reciprocal of 0 is some type of infinity, again, the safe answer is DNE. The safe answer from the right side is DNE. The safe answer in general is DNE. Okay, which is why these might occur as multiple choice questions on an exam. So the good news is we know it's some type of infinity. We don't know if that's true for the general limit, but the two one-sided should be. How do we determine it? Well, same thing. We're going to plug in a value to the left of pi halves. Now, here's where you got to be careful. If you don't know what the graph of secant looks like, you got to use the unit circle, okay? A number on the unit circle that is to the left of pi halves is not to the left of the y-axis. That's where you get kind of discombobulated because we're rotating around counterclockwise. If you go past the y-axis, you actually have bigger angles, right? And if I want an angle that's smaller than pi halves, I got to rotate back into quadrant 1. If we're looking at the graph of cosine or secant, then smaller than would be to the left. Now look, if you look just to the left of pi halves into quadrant 1, what's the sign of secant there in quadrant 1? Positive, right? Because cosine is the x and secant then would also be the x. So because x is positive in quadrant 1, so will the secant. And so this is positive infinity. What would be the sign to the right of pi halves? Well, again, if you're looking at the graph of secant, to the right would be greater than. But on the unit circle, greater than pi halves is continuing to rotate, which turns out to be to the left, into quadrant 2. In quadrant 2, x is negative, so cosine is negative, so secant is negative, right? And therefore, it's what type of infinity? Negative infinity. Very good. Negative infinity. And then the general limit, yeah, DNE is as good as it gets because they're different. Now, here's what I was saying about flipping. Let me show you. If you want to sketch cosine, for those of you who didn't have me, and I don't know if Mrs. Skurhawk did it, cosine I called chala, C for cosine, high axis, low axis, high. That's one cycle. So high axis, low axis, high. And this would be pi, this would be pi halves, this would be 3 pi halves, so on and so forth, this would be 2 pi. If you connected those dots like this, you get the graph of cosine. But secant is the reciprocal. So when you're graphing secant, I like to start with the zeros, where it crosses the x-axis. The reciprocal of 0 is some type of infinity. So those become vertical asymptotes. The high points are at 1. The reciprocal of 1 is 1, so those actually stay. The low points are at -1. The reciprocal of -1 is also -1, so those stay. And then in between there, like 1/2 becomes 2, 1/3 becomes 3, 1/5 becomes 5. So all you have to do is then turn them the other way towards the asymptotes. So that's what it looks like. All right. So now that you know what the graph looks like, which you don't really need it. Now let's look at pi halves and see if we did it correctly. From the left of pi halves, it's going up. And then from the right of pi halves, it's going down. Yeah. To get the graph of cosecant, very similarly, you would graph Sahala and do the same thing. Okay. All righty. So that's vertical asymptotes. If you plug into a function that's not a trig function, of course, and you get non-zero over 0, that's a conclusive result. That means there's a vertical asymptote there, and the limits can all be DNE safely, or if it's a one-sided limit, we can improve upon that. Okay, any questions on that? Vertical asymptotes. Yeah. In 5 minutes. Okay. Example 12. Go ahead and take a minute or two to do this. This is almost exactly like the warm-up. Now you kind of have the insight. I'm going to pause the recording and we'll go over it together. The warm-up was a preview of coming attractions.